us to go through each of these and write down what they mean so we know how to use them. Okay? The given statement. What line does it go on your proof always?
The right side.
Yeah, first line. These are all for the right side. They're all reasons, so they're all going to go in the reasons column. But it's the first line, always. Okay, next one is the vertical angles theorem. It tells you that vertical angles are always something. What do we think? Congruent, yeah. This is vertical angles are always congruent. So if you say something is a vertical angle, and then you say they're congruent, you use this theorem. Okay? So you have to know that that theorem means vertical angles are congruent. Next one is definition of a midpoint. What is a midpoint?
Middle of a line.
Yeah, so what you have to know for midpoint is that it divides it into two congruent pieces. So if you're saying point A is a midpoint and therefore this piece is congruent to this piece, you use the definition of midpoint. What about angle bisector? What does that mean? It bisects an angle. What does bisect mean?
Cut in the middle.
Yeah, it cuts it in half. So for angle bisector, you need to know that it's a ray that separates an angle into two congruent pieces. Cuts it in half. But these things you have to know just when you're given this phrase. Okay? All right angles are congruent. That's technically the right angles congruence theorem. All you have to say is all right angles are congruent. There's not really an explanation for that. They all equal 90, so they're congruent. But this right here will let us skip from right angles to congruence without going through the 90 degrees first. So we do need that. This symbol, what does this symbol mean? Perpendicular. So it says perpendicular lines form right angles. I'm probably going to use definition of perpendicular when I write this on my reasoning side.
What does that say?
Definition, D-E-F, def, of perpendicular, definition. So when I say definition of perpendicular, I'm using that to also say they form a right angle.
Bless you.
Okay?
Thank you.
So if you're ever saying, okay, I have perpendicular lines and therefore I have right angles, that's your definition of perpendicular. And then we have these four that we talked about last unit. When we have parallel lines, alternate interior angles are what? Congruent or supplementary? Congruent. So that's your alternate interior angles theorem. Same thing for exterior. When you have parallel lines, your alternate exterior angles are congruent. Corresponding angles are congruent when you have parallel lines. And consecutive interior angles are supplementary. So you have to know the angle relationship and write the word theorem behind it and use it to show congruence or supplementary. Base angles theorem. Does anyone remember what that one is? We talked about it on Friday. Not quite. Not add to 90. That's triangle sum, which we're not going to use a lot in proofs, but good thing to know. Has to do with isosceles triangles. Isosceles triangles have two congruent sides, so how many congruent angles? Two. So isosceles triangles have two congruent angles. Isosceles triangles have two congruent angles. Lots of shorthand there. But what that means is if you have a triangle and it's isosceles, those bottom base angles are also congruent. Definition of isosceles, that's just a triangle with two congruent sides. So if it states blank triangle is isosceles, you would use the definition to say that the sides are congruent. Okay? Or the base angles theorem to say that the angles are congruent. What about segment bisector? What does that mean? It bisects a segment, so it also cuts it in half. So for segment bisector, you would know that this piece is congruent to this piece.
Oh. Caleb, I think I know what Ryan's trying.
Then our last one, reflexive property of congruence. What does reflexive mean? We've used it multiple times now. If I say angle A and I ask you to use the reflexive property, what's angle A congruent to? Angle A, yeah, it's congruent to itself.
Genius, bro.
Or we could also do it with sides, like segment AB congruent to AB. Okay? So these are the common ones that you'll see in the proofs. There might be more. You might not use all of these ever, but that's what you'll see. Questions on those reasons, Charlie? Yeah,
Can I go when he comes back?
sure. And then from now on, no more going to the bathroom during lessons ever. Just go before you come.
You tried to trip me?
Okay. I want you guys to look up here real quick because we're going to talk about something. Before today, to show that two triangles were congruent, we had to show that all three angles over on this triangle were congruent to all three on this side. And all three of these sides corresponded to three on this side. Okay? Today we're going to do a shortcut. We no longer need all three sides and all three angles to match up. What if we just have two sides and the angle in between? So if we look over here, what I did is I drew a triangle with side lengths 6 and 7 unintentionally. And angle degree 97. I copied that over here. Side length 6 and 7, angle 97 degrees. We're gonna see, hold on, shush. We're gonna see how many different triangles I can make if these things are fixed. I would focus, meaning we have a fixed side, the angle in between, and the fixed other side. They're not changing, okay? Where do I have to move this to create a triangle?
To the bottom of the 7.
Yeah, like it has to hit A, right? If I do that, what do we notice?
It's the same.
Yeah, it's the same. I can't draw it perfectly. But close enough, it's the same. So just from having a matching side, angle, and side, we were guaranteed to get the same triangle. So now we don't need all 6 things to match between the two. We just need a side, an angle, and a side to match, and that's enough. So what we're going to do today is use that side, angle, side situation, Caden, to prove congruent triangles without having to go through all 6 things. Does that make sense? So before it was all 6 have to be congruent to all 6. Now we just need 3 specific ones. Okay? So back on your notes. Again, this is one of the hardest things we'll do in this class. First congruence theorem we have that lets us take a shortcut, meaning we don't need all 6 and all 6 congruence statements.
So we can do like 6 and 7.
No. Side, angle, side. It tells you that if two sides and the included angle,
Charlie, you have to pass them.
two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then they are congruent. So all we need now is if we look, AB is congruent to ED. So that's one of our sides. And for our other side, AC congruent to DF. And the included angle. All the included angle is it's the angle in between those two sides. So what angle is in between the pink and orange sides here? What's the name of it? We name an angle by 1 or 3 points, so not 2. What's this angle called? That's in between, or this angle. Angle A and angle D, yeah. So what we have here is two sides and the included angle. What you should notice is that you should be able to trace your finger from one side all the way to the next without having any gaps, meaning we can go from side, angle, side with nothing in between. That has to be the case. It has to be directly side angle side. Okay? All of the theorems that we name are going to be using the letters S and A to represent sides and angles. And the order of those letters kind of tells you the order that your picture should appear in. Meaning, if we have SAS, this means we have a side, an angle in the middle, and then another side on the other side. Another side on the other side of that angle. Okay? So this A in the middle can help you remember that the angle has to be in between the sides. Just like how it's shown with the SAS. This is different because we'll also have like AAS. Or like there's 6 different ones. Okay? So just be careful as to where that angle is located. This one's between those 2 angles. And since we're dealing with angles between sides or sides between angles this entire unit, we're going to practice it. So again, we use the word included for angles between sides or sides between angles. We want the included angle between PR, here's PR, and PS, here's PS. What do we think? Huh? Yeah, it'll be on P. It's going to be this angle right here. And the way we name it is we're going to trace out the angle. So say the letters as I'm tracing. We're going to start here. No, I'm tracing. You say the letters. What letter am I on? S. Should be moving eventually. P. Should be moving eventually. R. So that angle is angle SPR. Okay? That's the angle in between. It's the included angle. We can do the same thing for sides included, like included sides versus included angles. If we look at angle PRQ, that's this one. I could trace it out. P to R to Q. And PQR is this one. P to Q to R. What side, what segment is between those 2 purple angles? Yeah, QR right here, QR. So here, QR is the included side. It's between those 2 angles. And our very last one, the included angle between SR, here's SR, the green one, and RP. What do we think? If I start here and I trace it out, say the letters with me.
SRP.
SRP. It's this angle right in there. Okay? The key here is that if this angle is not included, meaning if instead of that yellow angle being congruent, we had like this angle up here and congruent to this angle, it wouldn't work. Okay? It has to be the angle in between your 2 sides. Questions so far before we get to using it? Okay, just another reminder, when we're doing stuff like this, here is when our hiddens come in. We talked about this a little bit, but just be aware, triangles can share a side like that one, or a side like this, or even like an angle. I'm on page 7 right now. They can share sides and angles. That's when we would use the reflexive property because it's the same thing. We need congruent to itself. Something else to be aware of is vertical angles are always congruent. And when we have parallel lines, those lines they create congruent angles. Page 7 of the notes packet you got last week. Like your actual note. Like remember, this is all just one packet. I just cut it in half so it's not as intimidating. Okay. So this was from page 7 of last week. But just be aware, this is when we're going to use these, is for proofs and when we're doing triangle congruence. So, back down to what we're doing today. There are going to be questions exactly like this on your test. It'll say determine if the triangles are congruent. If they are, state the theorem and the congruence statement. So, this first one. Right now, all we have is either all 6 things congruent to all 6 things, or side angle side. That's what we're doing here. One or the other. So if we match up our corresponding parts here, what's SR congruent to? LM. Okay, there's one. What is RT congruent to? MN. And then we have angle T and angle N. Clearly we don't have all 6 things. Okay? Do we have side angle side is the question. I have 2 sides in an angle, but is that angle included? Is it in between? No. So we can't use side angle side. And in general, this answer is no, because it's some sort of like side angle situation where there's a side in between instead of an angle in between. So you could say like SSA doesn't work or doesn't exist. Here's how you know it doesn't work, because you'll see a side angle situation a lot. If we turn this around, it spells something that I would never ask you to spell on a test. So SSA is not a thing, because I'll never have you write that word on a test. Do we all understand what I'm saying? So SSA is not a thing, but SAS is. Okay? Questions on that first one? Okay, the next one. Let's line up our corresponding parts. BC, what is it congruent to? ED, okay. And then I also have this angle here, angle CBD and angle BDE. I only have 2 things. I need at least one more for side angle side. What side would I need? If I go from side to angle, what side would I need? You would need BD. We have ED. So side, angle, you would need this side right here, BD. For the lower triangle. For the upper triangle, side, angle, what side would you need? You would need BD again. Is BD congruent to BD?
Yes.
Yeah. So here, we would kind of use the reflexive property, BD congruent to BD, by your reflexive POC. I'm kind of like outlining a proof here. We're not going to write a full one, but that's the idea. And then we would say, yes, the triangles are congruent by side, angle, side. Again, you jump from side to angle to side.
Do we have to like color it?
No, but it might help you. Like, I use the colors to see what parts line up. For example, B is pink, D is pink, so they have to be in the same spot. Let's put them in the first spot. And then if I kind of go along the yellow line, B goes to D, and D goes to B. So B goes to D, D goes to B. Or if I go the purple way, B would go to C, D would go to E, so C and E go together. So I kind of use the colors more to match up my corresponding parts and to see what I have. But they're not required, no. So we took the 2 things that we were given, one side and one angle. We said we had another side by the reflexive property, and then we used side, angle, side to state the triangles were congruent. Questions on that one? Okay. Last one. Let's look at what we know first. I know all 4 of these sides are the same. I also know, like we did last time, this red segment, E or ZX, is congruent to itself, and it's part of both triangles. So what I really have here is a side, side, side situation for each triangle, which is a thing, but we don't know it yet. So let's try to use side, angle, side. What type of triangle is WZX? If it looks like this, if I have 2 congruent sides, what type of triangle is it? It's isosceles. And when we went up here for our reasons, what do I know about isosceles triangles and their angles? I have 3 sides, I need an angle. Yeah, I have 2 equal angles. That's from my base angles theorem. So kind of to outline a proof here, I would use my base angles theorem. To get that this angle right here and this angle are congruent and the other two. And now I really have like 3 different versions of side, 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 Isaac, laptop, and headphones.
Okay, I had missed some of the notes, so can I just catch up with her?
No, you can listen and then you can catch up after.
Okay.
Okay. Here, base angles are congruent. We could have like a side angle side right there. We could have a side angle side right there. There's like 2 different options, one for each triangle. So this one is a yes by side angle side. And if I just write down my triangles here, W, X, Z, it'll kind of be like this on your test as well. It'll say, are they congruent? Yes or no. Give me the theorem, that's your side angle side, and then fill in the blank statement to write your congruent statement. So my question here is, what letter goes with letter W? W's over here. What letter over here would go with W? Y, okay. And then the other 2 can actually be, they can go either way. X can go with Z, or X can go with X. It does not matter. Technically well, no, it doesn't matter. We'll stick with that. So Y, Z, X for your other triangle. So again, all we're doing is checking if we have a side angle side situation. Questions on that one? Okay, it's proof time. We're going to get through 3 proofs and then we'll be done. Hopefully we get through 3. Second hour only got through 2. So, first line of any proof. Before I even look at it, what should I write down? Given. And for geometric proofs, I want us to write the given statement for each thing we have. So like we have 2 things that are given to us here. I want you to separate them. Write 1 on each line. So this is what we have. SQ congruent to PM and angle SQM congruent to PMQ. That's what we have currently. This is the exact, very similar to this one. We had the top and bottom sides congruent and we had those angles congruent. So all I need is 1 more side. What side would I need from the bottom triangle to do a side angle side situation? Not SM, that would not make the angle in between. Yeah, QM, perfect. I would need QM. I also need QM for the top triangle to get side angle side. So I need QM and QM. What property do we use when we say QM is congruent to itself? Reflexive. So this is our reflexive POC.
What does POC stand for again?
Property of congruence. Isaac, up, bud. Up. You should be listening right now and filling out your notes. Okay. Reflexive POC. Reflexive, what do you say? POC is property of congruence. I won't be super picky about that because there won't be any equality properties that we use this chapter. So if you just put reflexive, that's fine. Then our very last statement. Remember, these are our statements. These are the reasons. So on your cheat sheet, that list of things that I give you, that's your list for this column, the reasons column. Right off the bat, I could have filled out line number 4. What was line number 4? I knew what it was just from the question. What am I trying to prove?
Triangle QSM is congruent to triangle MPQ.
Yeah, perfect. We can always fill in that last line as well. Because we know that's where we have to get to. We have to prove it. We just have to figure out how we proved it. Well, we had a side, an angle, and a side. So what triangle congruence theorem did we use? It's not a trick question. We've only talked about one. SAS, side, angle, side. So again, you can kind of double check by tracing over your triangle again and making sure you get a side and then immediately an angle and then immediately another side with no sides or angles in between. Questions on the first proof? Okay, there will be a proof on your test, okay? It'll be a fill in the blank one, so it's kind of like this. There's like one or two little things that I kind of give you to push you in the right direction, but you gotta know how to do the rest of it, okay? So every day this week, we're gonna do like 3 or 4 proofs a day. On your homework, your proofs are drag and drop, so do not guess and check on those homework questions, okay? Actually try to go through it and figure out why you're dragging things where they need to be put and make sure it makes sense to you in your head, okay? Okay, next one. It says SP is congruent to TP. So we have those 2 yellow pieces congruent. It also says PQ bisects angle SPT. So that was a given statement. So I'm just going to fill out my proof really quick. Those are my 2 given statements.
Isn't the third one also given?
No, the third one is technically, yes, the picture shows it. I gave you the picture to put you in the right direction. The third one is not given, but somehow we went from an angle bisector to 2 congruent angles. If we look back at our reasons, again, we went from an angle bisector to 2 congruent angles. If we go to our reasons, which of these tells us that an angle bisector creates 2 congruent angles? Yeah, definition of angle bisector. If we look at the little picture that we drew 2 congruent angles. So by the definition of angle bisector, we know that those 2 angles are congruent. And we also kind of know that because we use this word bisect from the line above. Okay? So now we have this situation. I'm going to trace it out. We have a side. We have an angle. What side do I need to handle this left triangle for side angle side? PQ. Boom. For the right triangle, if I have a side and angle, what side do I need? PQ. So I'm going to say PQ is congruent to PQ. Because that's the third side that I need for both triangles. What property do I use to say that everything's congruent to itself? Reflexive. For the most part, reflexive is going to be the only one, for the most part, the only one of those POCs that you use for this unit. Okay? Not transitive or symmetric. They might show up, but probably not. And then our very last statement, we have our triangles congruent. We know that because we went through a side angle side situation for each. So SAS is our reasoning there. Side angle side. Questions on that one? We're almost done.
Jordan, stop flying.
I don't like to throw things at people.
I feel like you.
Wake up. I really don't even care if you sleep
No,
as long as you don't snore.
You should get a bell.
Just ring it in your ear. That's not bad. I have a cowbell at home. Those are loud.
I don't know about all
You
that.
should bring that.
Maybe I will. I don't care if you sleep as long as you know that you're losing the content and I'm not going to catch you up. Okay. Last proof. It says AC is congruent to EC. So I have, Okay. I have AC congruent to EC right there. That's one of my sides. That goes right into my first line. And what's the reason for me writing that down? It's given. Just by writing those 2 things, you have earned 1 out of 6 points that this proof is worth. Okay? Not bad. Charlie.
I have 3 given.
There are 3 givens. So actually, you really get, in this case, 3 out of 6 free points just from writing given. So I'm going to write all those down, and then we'll talk about what they mean. Okay, the second given statement is that DC is congruent to BC. So that's my orange pieces. And then my last statement is that AE, so this line is perpendicular to this line. What do we know about perpendicular lines? Not necessarily. Perpendicular lines, we need an angle. What kind of angles do perpendicular lines make? Right angles. So I know.
I was close.
Oh, you didn't? I thought Ayanna said right angles. Yeah. Okay, someone said it. Okay. So I know that these 2 angles are a right angle, which also means they're congruent. Okay? We just can't say all of that in one step. We have to take it piece by piece. We know that those angles were right angles, so angle DCE and BCA are right angles. You just have to write it down. Because the definition of perpendicular doesn't say that it gives you 2 congruent angles. It says you get 2 right angles. So by the definition of perpendicular lines create 2 right angles. So we have 2 right angles. Now, what up here in our reason bank do you think we could use to say that since this was a right angle and this was a right angle, they are congruent? Look at your reasons bank. What deals with right angles being the same? Perfect. Yeah, all right angles are congruent. This one right here. That's technically your right angles congruence theorem, but I'm fine for easy remembering if we just say, since all right angles are congruent, we can now say that those 2 right angles that we had in the previous step are congruent. Angle DCE. This is flipped around. DCE and BCA. So if we kind of fill out our picture, here's what we have now with our colors. We can say that the triangles are congruent by which theorem? What do we have if I trace this out? Say it with me. What's this? Side or angle? Side. What's this one? Angle. Side is working. Side. Okay. So by side, angle, side, we will say that triangle, and it already gives it to us up here, ABC congruent to triangle EDC. So, the next 2 days, we're going to go over 4 more of these theorems. There's not just SAS. We have 4 other ones. So it's going to be a similar vibe to this every day. Figure out what you have, sides and angles wise, and figure out what theorem you need to use. Questions over this? Okay, if you did not do your learning check, it is due tonight at midnight. And you'll have 4.4 homework on big ideas. Real quick, because I don't know if I've mentioned this, especially for this part. This homework is hard, okay? You're writing proofs. If you get stuck on big ideas, you click a button. It says live tutor. A real person, not AI, not ChatGPT, not a robot, a real person will come up on your computer screen and talk you through the problem, okay? So before you email me saying you didn't understand it, or before you come to ACK Lab and it's 5 days late because you didn't understand it, press the live tutor button. They will help you from the hours of like 4 to 10 or 4 to midnight, okay? So before you give up when you're confused, press the live tutor button. Okay.